Welcome to the second day of the Belgian AI Week. And I hope you have enjoyed the first day by learning more about Belgium's regional and national strategies. And the second day of the Belgian AI Week is all about AI uptake by the private sector. And I'm very happy to be able to introduce today's opening keynote. The keynote will be delivered by Robbe Sneyders from ML6. He's our head of delivery and leads our technical team. So he's responsible for the successful delivery of all of our projects. He works closely together with our project teams and our research teams to ensure that we can provide our clients with the right expertise at the right time. Robbe is a firm believer in open source, and he has made some major contributions to Apache Beam, amongst others. And Robbe is going to talk about how we can shorten the cycle from AI research to practical applications in the industry. Now, at the end of the keynote, we will have some time for a Q&A, so you can submit your questions via chat. Without further ado, Robbe, the word is yours.
All right, thank you, Julie. I don't know if my presentation is already visible as well. There it is, thank you. So yeah, thanks again. As Julie already mentioned, I'm Robbe Sneyders, head of delivery at ML6. Maybe one thing she didn't explicitly mention is what one of the nicest things about my role, which is that I'm involved with a lot of our key projects. And today I want to share some learnings from those projects, specifically how to move AI from research to applying it in the industry. I'll keep it short and sweet. So again, as Julie already said, there will be plenty of time to answer questions at the end. Now, for who doesn't know ML6, we're a machine learning services company, which means that we help our clients with AI advisory and implementation. So we're currently with around 90 people across 5 offices in 4 countries, with our headquarters in Ghent in Belgium. We're growing fast, and we're a partner of Google Cloud with a specialization in machine learning, which means that Google will come to us when one of their clients needs help implementing AI on Google Cloud. We spend a lot of time on applied research and on contributing both code and models to the open source community. So we've been doing this for quite some time, and over that time, we've collaborated with over 100 customers across industries, from life sciences to manufacturing to financial services and media. And this provides us with the unique capability to build and share insights and best practices across industries. So that's what we'll try to do today as well. So first, I quickly want to talk about our vision and why I'm presenting this talk today. So our vision at ML6 is to accelerate intelligence, because we believe that by growing talent and advancing technology, we can work with our customers to have a positive impact both on their business and on society. So I'll be focusing mostly on the technology pillar today. So we really believe that intelligent technology can create an impact and accelerate progress. And that's why we try to shorten the cycle from research to industry by doing applied research and innovation, both internally and at our clients. So over the past few years, research in AI has really been booming, with new algorithms and network architectures coming out continuously and improving the state of the art. If you haven't been living under a rock, you've probably heard about the GPT-2 and GPT-3 models, which are general language models, but are mostly famous for their enormous improvement in text generation. Whole articles have been written with these models that are almost indistinguishable from human written ones. Or maybe you've heard about the kind of next iteration, which is called DALL-E, and which is a similar network but trained on both text and images, which allows it to generate images from text prompts. So this is quite amazing. If you look at the example on the slide, if you just ask it to show you an armchair in the shape of an avocado, you get these very, very great results. Now, there is a trend noticeable in these models as well, and that is that they tend to get bigger and bigger and need more and more data. So earlier this year, Google actually released the Switch Transformer model, which is the first model with over 1 trillion parameters. Now, the data and compute needed to train such a model is something that mere mortals like us can only dream of, and is something that is, for instance, also hard to achieve for smaller languages such as Dutch, which is, of course, an opportunity as well. Because luckily the AI research community is quite open in sharing ideas, code, and models. And with some clever tricks, we were able to fine-tune an existing English GPT-2 model on the Dutch language. So this means that there's now a Dutch GPT-2 model for pennies on the dollar, and you can try it yourself on our website. But why would we stop there when we can apply this research on our customers' data as well, to provide insights in what can be done with new technology and unlocking new opportunities? So this, for instance, what we did when we trained the text generation model on 1 million Belgian real estate deeds. Now, applied research, which is what I would call this, is often considered less sexy because a lot of people think that it's simply applying methods that already exist. But actually, it still takes significant technical work, algorithmic and engineering, but also a lot of non-technical challenges to solve before you can really start generating value with these new models and the results of that research. But when it works, the results can be great. So I want to start by showing one of our use cases where we did production planning optimization for fast-moving consumer goods. So using novel methods here, we were able to optimize the production of the goods across the production lines by 1%, which might not sound like much, but still it created a tremendous value by increasing the annually recurring revenue by 6 million and returning 1,200% on investment. So this is really about getting that additional 1%, which is what you need the newest methods for. But it's not all about technology, as you can see in our next use case. It's also about choosing the right use cases to achieve the maximum impact. Like when we built a real estate matching engine. So we achieved an accuracy of 20%, which doesn't sound that impressive. But for this use case, it clearly is, because even though the technology played an important part here, a really important part was to make some very important business and design decisions that allowed us to achieve a 600% rise in efficiency of the users using the system. So it's not just about technology. Technology is always important, but it's also very important to find the right use case that you can apply the technology to. So I will not go into more detail about this use case, but if you want to hear about it, make sure to follow the talk by my colleague Jan van Looy this afternoon at 15:30. So how do you get to the point as an organization where you're ready to create value with AI, where you're ready to move from research to production? Well, there's a bunch of frameworks that will tell you what you need. I've pictured two here, one from Google and one from Element AI, but you can see that there's a lot of similarities between both. They both talk about data, people, technology, and process, for instance. So today I'll present to you our own roadmap from research to industry, based on the learnings we have gathered from our own applied research and our customer projects. Now, you'll notice that it touches on a lot of the domains mentioned in the framework, but we'll focus on 4 specific points that we see are really important. The first one being data availability. The second one, organization. We'll look at the machine learning project lifecycle, and then finally at ML ops. So let's start with the data availability. I know that this isn't new, and you've heard it 1,000 times before, but that's because it's true, and I'll promise to keep it short. But to create value with AI, you need access to data. And I'm sorry to say, but if you don't have analytics or dashboarding yet, you probably have no access to clean data. So there's a lot of data engineering needed before you can start thinking about AI. But having easy access to clean data will really drive innovation. And just to show that getting your data ready doesn't need to be a net cost, I brought another use case to show that it can provide tremendous value in itself. So here we did waste prevention for a wine bottling company. And before applying any machine learning, we already achieved a 50% waste reduction by just providing insights into their data. So that's not bad for some dashboarding. So I promise to keep it short. So next, I want to look at the organizational level. So the first step is, of course, to make sure that you have the capabilities to deliver AI projects. This can be done either internally by collaborating with a third party or a combination of both. Now, a lot of companies seem to hire a data scientist or an AI team and expect them to start solving. ideally as shielded from business as possible, because they are not ready to change, and with IT just as a dependency for data deployments. Now, this leads to the AI team having a hard time getting hands-on on the data, and that they lack the domain knowledge that is needed to define the use cases and to engineer valuable features. And then when finally a model is produced, it takes a long time to get to production. When it gets there, it is barely used and quickly gets outdated. So real-world AI applications really require data sharing and a combination of domain knowledge and technical expertise. So that's why you need to go across organizational boundaries to create this value. You need the business side to have the domain knowledge to define use cases and to measure the business value. And you need IT to know how your solutions will fit into existing systems and make sure that your models make it to production and can stay there. In the end, you want to be able to spot new opportunities, both from a business perspective, as from the possibilities unlocked by emerging technologies, like you can do with applied research. And for this, you need to bring your people together. Let me quickly show you how we do this at ML6. This is, of course, tailored to a machine learning services company and will probably not work for you, but I still hope it can be valuable to get some insights in how we work. So internally, we work in squads and chapters, where chapters are expert teams that focus on a specific domain, for instance, on NLP or software architecture. So they are the teams that focus on applied research to build our knowledge and share it with everyone inside. Then we have our squads, which are multidisciplinary teams that deliver projects with our customers. And as you can see, each squad is a combination of different domain experts. Because, like I said, it's important to bring together the different expertises and the knowledge needed to successfully deliver a project. Now, it's not clear from the picture, but everyone at ML6 is actually part of both a squad and a chapter, making sure that the road from applied research to application is as small as possible, and making sure that everyone has an innovation mindset. So now that we have the prerequisites out of the way, let's start talking about ML projects. So we'll go over the typical project lifecycle that makes sure that your machine learning projects actually create value. So our project lifecycle exists of a proof of concept, an MVP, and finally machine learning in production. And there's a lot of different names for this, and some companies might use different stages, but this is the progression that we use. And it's important to note that, of course, necessary investments for each stage are exponential. So we have more proof of concept than MVPs and more MVPs than applications in production. This kind of approach is, of course, not unique to machine learning, but it is even more important here due to its inherent experimental nature. You never know upfront how good your results will be and what you will be able to achieve by training a model on your data. So we'll now have a look at each of these stages and discuss important machine learning specific focus points before applying this project lifecycle to 2 additional use cases to see how they translate to the real world. So in the proof of concept, we aim to demonstrate the feasibility and the added value of intelligent technology to the use case. To limit the complexity and time of the proof of concept, we break the problem down to its simplest form and work on a static data set. So we start by exploring the data and selecting the right metric. And important to note is that the right metric depends on the use case, but it's probably not just model accuracy. Selecting a good metric requires domain knowledge, and we'll see some examples of better metrics when we talk about the use cases. Now, the goal here is to enable testing and feedback by stakeholders as fast as possible. And if there's no indication that the solution can actually deliver value, it's important to fail early. If the solution does seem promising, it's important to define next steps and dependencies to move forward. And these will often be questions that you want to answer during the next MVP stage. So during the MVP stage, the goal is to demonstrate that the solution works in a real-life environment. So you want to move from your static proof of concept data set to a more realistic one, and you want to enable user testing as fast as possible. This is also a great opportunity to collect additional data and feedback, which you can then later use for further model improvements. Now, it's critical to understand your audience at this point. Users might not care about how well your model works, but need something that they can use. So if the system is not useful, your MVP is not a success, independent of how great your model accuracy is. And then finally, when moving to production, we of course start to focus more on security, scalability, monitoring, and so on. But we also want to automate the complete workflow so manual errors can be prevented and the model can regularly be retrained to combat issues such as, for instance, data drift, where your data changes over time compared to the data you trained on, and to keep improving the model's performance. Now, it's important to keep collecting data and feedback continuously once in production, because in contrast to traditional software, for machine learning projects, this is not the end. The system can keep improving over time, both by retraining and by further developing the models. And for this, you will, of course, need to collect the data. Now, finally, since you'll roll out the application to all your users, it's important to focus on education as well. The better your users understand the application and know how to work with it, the more value it can create. So that was the theory. Let's now see how it matches our use cases. So for the first one, we will look at a carpet folding use case where the goal is to automatically detect where to fold a carpet, even for new carpet types that it has never seen before. So on the proof of concept, we dumbed out the problem and we focused on images instead of video. So we took separate images from the carpet on the assembly line and we tried to predict where to fold it. Now, faulty predictions could stop the assembly line and lead to a huge cost. And that is why, as a metric here, we didn't choose a metric to see how well our predictions or how good our predictions are, but we chose a metric that takes into account the percent of predictions that fall within an error range. And this is because the biggest failure is not created by doing a 1% better prediction, but by doing less faulty predictions. So I'm moving to the MVP. We want to work on actual video data. And here we, of course, get the opportunity as well to add smoothing between our frame-by-frame predictions. So again, since we take a next step, it's important to evaluate our metric as well. So now we can actually change it to the percentage of correctly predicted carpets, because our individual predictions are not that important anymore, since you'll smooth them out across frames. So you really want to focus on how many faulty carpets you have that would, again, stop the assembly line. So by using this metric, we would come as close as possible to the actual generated value. Now, what we did in the MVP as well is to integrate the system with the assembly line, but only to shadow the current solution. But what we did enable is that operators could run tests, so they could let our system take over the assembly line to see how well it performed. Now, while it is shadowing the current system, we can, of course, start collecting additional data as well, which, again, will be very important to keep improving and retraining the model. So now we're finally ready to move to production, which means adding automatic retraining pipelines, monitoring, and a manual fallback system. So again, we want to keep collecting data and automatically retrain our models to make sure that we can handle new types of carpets and to keep improving. And finally, this is also the stage where the system is ready to fully take over the assembly line. Now, another use case where we can really show the progression of the project stages is a use case where we matched online courses to users. So during the proof of concept, again, we simplified the use case and we focused on one specific type of course to match users to. So especially in ranking and matching, metrics can be hard since the problem is quite subjective. And two different people might rank a list of matches differently. And it's often even hard to compare two similar entries to each other and really say, like, this one is better than the other. So as a metric here, we therefore compared the output of the model to a manual search by a real person using the current system. And we had the results evaluated by multiple users. So this is maybe not the most scalable approach, but since the metric really is subjective, we also needed some subjective input to compare the results. It's very hard to build an objective metric for a ranking and matching system. Now, for the MVP, we built a system that could find matching users for a wider area of courses, and we exposed the system to a limited set of employees that could use it in addition to their current system. So again, this allowed us to gather additional feedback for further model improvements without being a critical dependency already. Now, an interesting learning here, and one that we've noticed on a lot of projects, is that we were missing some basic non-machine learning features to make the system useful. So sometimes, especially in a search, for instance, a basic filter can be more important to users than better search results. So yeah, it's really important to know your audience, to make sure that you build something useful, which can be more important than getting the best results. So finally, moving to production, we again added automation, scalability, and monitoring, and we added or we activated bidirectional matching on the full database. So now, both employees could search for matching users for courses, but users on the website could also find matching courses for their taste. And over time, we could collect data from both sides and use it to improve the underlying system as a whole. So I hope this really sheds some light on the lifecycle of a machine learning project and what you need to pay attention to at specific phases in the process. But as you might have noticed, we kind of brushed off some of the technical difficulties that might arise during the process. And we mostly focused on making sure that you create business value. But now I want to focus on the technical side as well, and this is why we need to talk about MLOps. Because from a technical standpoint, training a machine learning model on a holdout data set is not the hard part. The real challenge is to build an integrated machine learning system and to continuously operate it in production. And if you've been paying attention, you might notice that these descriptions match definitions of our proof of concept and production system. So this really shows that this is not an easy step to make. And there's really a lot of engineering and design involved to make sure that you have a machine learning system that can really use the results of your model. And this is a very famous picture, which I like to show. And it shows that only a small fraction of a real-world machine learning system is actually model code. So this picture clearly shows why bringing a model to production can be such a big investment, and why you want to evaluate your solution using proof of concepts and MVPs first. Now, a lot of the complexities of a machine learning system can be explained by looking at the axis of change in the system. So besides the code, changes to machine learning models and the data used to train those models are additional types of changes that can occur in the system. So they also need to be managed and really baked into your machine learning delivery process. For instance, testing a machine learning system is more involved than testing other software systems, since in addition to the typical unit and integration tests, you also need data validation, trained model quality evaluation, and model validation. Deployments are also not as simple as just deploying an offline ML model as a prediction service, because often you'll need to deploy a multi-step pipeline to make sure that your model gets retrained and is deployed in the right order. And finally, machine learning models can have reduced performance due to a lot of reasons. So not just due to like bugs in your code, but also due to evolving data. So models can really decay in more ways than conventional software, which is why you need to make sure that you continuously retrain and that you also track the results of your model over time. So this clearly shows that the lifecycle of a machine learning model is so complex that it is unlikely to be properly managed if the ownership is changed throughout the lifecycle. So the wall of confusion which we know from traditional software development is even higher in machine learning. And this is why you need MLOps to unify your machine learning development and your system operations. Now, while there's a lot of MLOps tooling available, it's important to understand that MLOps is about culture and practices, and tooling alone won't help you. So I won't go into too much detail about MLOps, but I want to highlight some important practices. So the first one is to work in cross-functional autonomous teams. So this ties back until the bringing your people together we saw earlier, but here it's more on a technical level as well. You really need to work together with your data scientists and your broad IT organization to make sure that your models can make it to production. A second one is to really focus on end-to-end workflow automation so you can prevent bugs, you can easily retrain your model and keep improving. And then the third one is to version control your data and models so you can keep track of experiments and how they were brought to production, what data you trained your model on, how you improved the results of your model, and so on. So together, these will help you handle the complexities of a machine learning system and help you move from experiment to production faster. And this is important because you need to be able to keep experimenting, to try out new technologies, and to be able to move them to production fast. Now, at the end, that is a good takeaway for our whole AI roadmap. So while I've tried to provide you with the necessary tools and the prerequisites that we think are needed to be able to deliver AI, what you really need to move AI from research to industry is to create a complete culture of innovation. So it's not about, you cannot just apply some small fixes and some small processes. You need to make sure that you have a culture of innovation and that you have an AI strategy that clearly shows where you want to go. So that was it. Thank you all for listening. And then I'll now open the floor for questions.
Yes, so thank you, Robbe, for this inspiring talk. We already received 2 questions via chat, but so feel free all to continue submitting your questions and we will tackle them one by one. All right, so the first question came from Sam de Boeuf. He's asking how you define the business metrics for the POC.
Yes, so I quickly touched upon it in the use cases. So I really think it's starting from your use case and seeing how you want to create value with it. As I mentioned, for the carpet folding one, for instance, the value does not come from getting a 1% better prediction on where to fold, but the value comes from making sure that your production line can keep running with a high enough quality. So there it's logical to start with a metric like how it's actually a metric for uptime of your assembly line. And then we translate it, of course, to the model accuracy. How can we achieve this uptime? So in a proof of concept, this is all you have. So there isn't any uptime metric you can track yet, since you're mostly focusing on trying out the intelligent technology as the first step. So you start from the business case and try to translate it to a technical metric, which you can already track.
All right, thank you, Robbe. The second question is from Timo, and he's asking what is the most unappreciated part that differentiates bringing ML products into production compared to bringing traditional software into production?
Yeah, that's a good question. And I think it's about the axis of change that I showed as well. There's a lot you need to track. You need to track your models, you need to track your data, and you need to track your software, which means that it's often not a one-step deployment, but you really need automated pipelines that combine the deployment of all of these different domains. So you might even have to deploy new data into a system when you have a new model, because your new model can work on a different schema of data. So you really need to make sure that they're constantly aligned. And this is, I think, the hardest part, because you need to keep track of a lot more things, and you really need a step-by-step pipeline to handle this complexity.
Thank you, Robbe. Third question is by Melis. She's asking whether we can think of ML ops from the perspective that it also reduces risks in an ethical perspective.
Yeah, thanks again for the question. I think it generally can, but again, it's about the culture. So the tooling alone won't help you, but it's really about having the cross-functional teams as well, making sure that the people thinking about the improvements of the system, but also about the implications are brought together and that they can collaborate. So you could even, as an advantage have, of course, that you really start thinking about the ethical perspective as a goal and rally your technical people to help solve it. And I think it's a team effort. It's something that you need to bring into the culture, and that is, of course, something that MLOps does allow.
All right, great. We have a more technical question, also from Timo K. So it's about production. He's asking whether we use end-to-end frameworks such as Kubeflow, and whether we use different frameworks stitched together or cloud solutions, and what the pros and cons are.
Yes. Thanks. So that's an interesting question as well. So we actually do use Kubeflow, and on a higher level also TensorFlow Extended. So these are the tools that we choose for our ML ops flow, let's say. But we also use the managed version of those. So Google Cloud, for instance, offers AI platform pipelines, which is Kubeflow pipelines, but in a managed version. And there, of course, the advantage is that you don't need as much setup to get started. It's very easy to automate your flows. But of course, there's the contradiction or the downside, which you also always have with managed services, is that you have less freedom. So you're tied to the versions available on the hosted versions. And if you need new features, they might not be available. If you need to tweak some configuration that is not tweakable in the managed version, again, the self-hosted version can be more useful here. But I think the most important part is not which framework you use, it's what the framework does as well. And I think it's mostly about splitting your pipelines into reusable components, containerizing your experiments, and moving forward that way. And I think almost all MLOps frameworks are focused on that, of course.
Great. Then we have another question from Sam about how we validate models in production, and especially how we calculate the metrics when there's no labeled data.
Yes. So we often use a two-step approach for this. So we try to have some kind of labeled data, but as we mentioned, it's not always easy. For instance, for a rank and match problem, it's not easy to see which model performs best. But what you can always do is have a kind of test data set which shows you that the results of your model make sense. So that is the first step of automated model validation. And even for some use cases, of course, you can build a better technical model validation. That's if you look at a vision classification task, for instance, where you can have clear labeled data, then you can use a very good automatic model validation. But the next step you can do as well, of course, is A/B testing. So once you validate the model, make sure that your results make sense and that it's not really bad. Then you can put it into production next to your current model, start shifting some traffic to see how it really performs. And so for us, it's really those two steps that we take. And depends on the use case where the most weight will be. For some, you can do it mostly automated. For some, you need to have real user testing.
Thank you, Robbe. And we have a question from Brent that is more about predictive maintenance, and who's asking how we monitor ML models in production when the true labels on the live data will only be available in the future.
Yeah, that's a very good question. I don't think there's any big shortcuts to take here. So you need to keep monitoring the results of your models when they become active, of course. Before you have the labels of your model, it's really hard to say anything. But even with let's say time series forecasts or forecasts into the future, you can really look for maybe not the true labels yet, but for some proxies. Again, with predictive maintenance as well, you might not have the true labels, but you might already have a small sample size that you can rely on and that you can start monitoring from the start. But I think this is still a very hard problem to solve. And to get any real results, you'll need to wait for your labels and keep retraining in the meantime.
All right. Then the next and final question for now is from Nick, and it's about whether we have any good practices to test robustness of the models we deploy beyond validation performance measures.
Yes, thank you. So again, there's, I think, a couple of things you can do. You can play with the inputs yourself. So by doing data augmentation or by changing some of the input parameters to really measure the robustness of your models. So this is something you can do for model validation and something that exists for different kinds of models. The second one, of course, is again the A/B testing that can really help here, because in A/B testing, you're testing in a real life environment, and you're also really testing the robustness over every kind of data that you might find in the live system.
All right, thank you, Robbe. We have another question that came in. For companies who are willing to apply machine learning solutions, would you advise them to employ a data scientist, or what would be a good starting point? Robbe? There seems to be a small connection issue.
I'm sorry.
Back.
The latest research and networking hasn't made it to my apartment yet. Again, I think this is a great question. And I would advise to build internal capabilities when you want to apply machine learning solutions. So you don't need to do everything yourself. Of course, otherwise we wouldn't be able to survive as a company. But I also don't think it's good to rely completely on external parties. So that's why we also focus a lot on upskilling. So we really want to bring the knowledge to our clients and make sure that we can collaborate with them and that they can also define their AI roadmap together with us with the skill set that they need, and that they can manage their machine learning systems in production themselves as well.
And I think that was a great question to end on. So big thank you to the audience, and also for all of the interesting questions. To answer the question about whether the slides will be available, the slides will not be shared separately, but the recording will be online to follow afterwards. I would also kindly like to invite you all to follow us on Twitter and on Instagram, and you can also reach out to Robbe if you have any additional questions. On our channels, we continue sharing blog posts and interesting materials for you to keep on learning. And finally, I'd like to invite you to the other sessions today. So at 10 a.m., there's a session about how AI can contribute to solving mobility and transport challenges. At 11 a.m., there is a session from IBM about human-centered AI. There's also a session about energy efficiency in AI by IMEC at 11 a.m. And then finally, I also want to all invite you to our other session at 3:30 p.m. Where Jan van Looy is going to be talking with Philippe Meire about one of our use cases in the prop tech sector. So with that, thank you all, and have a great day at the Belgian AI Week.